So now we will talk briefly about the state. We have been using configuration tools for ages, all the configuration management tools that we're all familiar with, Ansible, your homegrown bash scripts, napalm, chef, what have you. We configure things with tools that we know and love. But the problem is that we monitor them with different tools. When you configure things on your network, you probably monitor them with Grafana, zabbix, Nokia, something that has no idea how you actually configured it. This is what we are trying to solve in EDA as well. In EDA, we want to have a streaming telemetry capable system that knows what you configured, because we just configured this fabric, right? But we also want to know the health of the fabric. What is the health of the fabric? It's a very complex question to answer. What makes up a fabric? How would Grafana and your Prometheus database know what makes up a fabric? Unless you make a lot of heavy computational stuff with PromptQL or any query languages, you will never know. This is what we try to solve with EDA by saying that you can have a status or state of your network, right? This is also contributes to the reliability of your network operations, because you can see what exactly the health of my intent is. So what I will show here is, again, the Fabric app using my Fabric in EDA, and there is this status information on the right-hand side that you can look at, and it has the health 100 and the health score. So I can see, is my fabric healthy exactly or not? And it is up for EDA and you, because you can see the source code of the application to understand how we calculate the health score. Now, again, this is not something that easily visualizable to people, but we made it a little bit better because every application can have its own dashboard. And for the Fabric's dashboard, you can actually see what makes up your fabric and if you have any alarms dedicated to this fabric. So I have these 2 nodes, 1 spines, 2 leaves, 1 spine. There are no alarms. All of the components of my fabric, which is interfaces in the default VRF, routers in the default VRF, interswitch links, they all now green. But when we deployed it during the deployment phase, it was not green. So let me show you this. If I go to my fabric and I say, you know what? The V6 was a bold move, but I'm even cooler. I want to have unnumbered BGP underlay. I don't want to deal with IP addresses at all. So I go here, remove my IPv6 pool, and I select unnumbered IPv6. And yeah, let's commit it directly. So we are committing this stuff. It will do a lot of things. But what most importantly, if you go to summary right now, you will see that, yeah, well, it converged pretty fast. But you will be able to see that some of the resources will be transitioning from healthy state to degraded or down during the period when BGP is converging. So now it was super fast. We did not see it here, but when we did just the initial deployment of the fabric, you saw that the health was 50 because BGP peers were not converged. But once we changed to a number, it just happened very fast. But yeah, looking at the state of the intent is how you can correlate things out. So now, you remember that we were talking about the operations, simplification of doing stuff that deals with state. The state is very important to EDA. Everything that we worked with was partly because of the capabilities we have for state management. And correlating the state with the intent is what makes it nice, easy for you, complicated for us because we need to do quite some advanced stuff for that. But nevertheless, there are different things how you can make use of the fancy technologies that we have on SO Linux specifically and in EDA that drives it, right? One of the interesting parts that have been always discussed in kind of autocons, nanogs, different nogs, and different events is that people want to have a network-wide query language. Just connecting to nodes like I did to different leaves, different spines, and doing this, show commands, the usual thing. We've been doing this for ages. But at the same time, we lack the network wideness of this operation. You can, of course, open 55 tabs in MobaXterm and do show command and see the result. Will it be effective, though? Will it be useful when you have so many nodes, and the bigger we have the networks, the more complex the problems becomes. So what if you would be able to query your network live efficiently with a language that is kind of easy to understand when we type it in? That is what we call the EDA query language, and it comes part of the EDA system that allows you to query the full range of your network. Remember that we also mentioned multi-vendor a couple of times. This good stuff will work with multi-vendor as well. So what EQL is quite simple to understand. The EQL is a query language that allows you to log into your system, open up the query tab. It's right there, queries. And what you see is just the input string for your query, right? What can you do with that? You can do a lot of things. The basic thing that you would probably want to do is just to get some information from the nodes that you manage. So if I start typing a dot here, which is the root of my query, it will auto-suggest me a few continuations of my query. Since my objects are all placed in a namespace, this is the object that I want to query right now, they will be in a namespace. So I use a namespace.node, which kind of means that we will take some information from the nodes, right? If my path contains a namespace and a node, we're talking about the nodes. So how about we go to node.srl .interface and click enter. So what we get now is a live query that resulted in concurrent calls to the state engine in our EDA system that resulted in taking the data from the nodes live and showing it here. So I have, if you can see, this count says 112. I have 112 interfaces in my network. And it's all in this data table, right? I see them all. So this is how I can list all of my interfaces without connecting to the nodes. The path, though, is something that you may have noticed is familiar to a YANG path, or a path from the configuration tree of SR Linux, and that is exactly what it is. When you go to .namespace.node.srl, in our case for SR Linux, you enter into this query pattern of a YANG path. You follow what we have in YANG, which means that under interface, we have subinterface, right? Under subinterface, we have IPv6. And under IPv6, we have an address. If we do this, we'll list all the 6 addresses from all of the nodes. You see how quick that was, like it was instantaneous. What happens in the back end is we reach to the nodes, we establish a streaming subscription, so that if I go to the node and I shut one of these interfaces down, it will be immediately retracted from the table because it's all streamed. There is no polling, there is no fetching, there is no state even. We don't persist this data. It all comes live from the network. Now, that's good, right? That is also quite fun. As I said, we can see the results live. I will not shut down the interface right away because I want to show something else. What if we want to see what interfaces we have that are not the management zeros? I don't care what management interfaces I have. There is no point in showing that. So instead of typing this stuff, I will just copy paste. So now this query continues after IPv46 with a where clause. So the where clause allows you to filter. You can say, I want to display the IP addresses where my name not in this pattern. I don't want to see management zero interfaces. If I run this, management zero interfaces are gone. Now I have 8 interfaces. And as you can see, these are 1, 2, 1, 2 interfaces on the leaves and 4 interfaces on the spine. This is our topology. Now I have IP prefixes listed for them. All good and fun. But this is kind of quite tedious, right? This is a lot of, not a lot, it's just a long string, but it's more or less comprehensible. We understand what's going on. But of course, in this day and age, nothing comes off without some AI hype-ish stuff, right? So we have a natural language query, which allows you to ask your network silly questions. You do this couple of times, really. It's mostly for you to learn the query language rather than use it all the time. So instead of figuring out what path do I need to use to query my V6 interfaces, I could have said, show me all interfaces where MTU, for example, is more than 2000. Natural language query will figure out which table it needs to look at, and what it does, instead of going and have a nice hallucination act, it will try and figure out the query that it needs to use. So it will not go to the nodes, fetch all these million tokens and shovel it to AA Cloud. Instead, it will try to figure out which query it can use to achieve what you want. And these queries then run on the system to return you all of the information back at you, right? Which is what I think is super important now with this AI hype cycle, to understand I don't want my operations to rely on a bunch of MCP servers created in a night by another white coder. What I want is a reliable data that I can use. If AI can help me figure out what query I should use, fine, but I don't want it to imagine how my configuration should look like. I want it to help me get to a reliable input that I can use in my system. And this is exactly what NQL, or natural language query, does for me. You can also say something, of course, you can say different things in different languages, right? It's multi-language. Like French people will be very happy to see that. I don't have any French patterns here as well, but we can try it out later if you find me. But for example, list all users that have been configured across my fabric. We configured this test user. Remember, we had it in our previous exercise. And now it sees that. It sees that the test user is there. Like, my test user is on my system, but now I can go and remove this test user. So I can connect to my EDA system again. Let me see, this is my node users. We remove the test user. I don't need it anymore. I commit. And in my table, it's gone. I have not refreshed it. The user test was there. I committed removal of a test user. The query updates live. So WebSockets from the UI to the system, the student telemetry from the nodes to EDA. EDA reacts with this pops up mechanism back to UI. Magic stuff. Okay, and maybe to top it off, some other things that you can do, of course, you can ask, when was the last time admin user logged in? Or where was my MAC address in my fabric? It will be able to figure out the request that you have, send it as a query input to the system, and the system will return the live results back at you. Important thing is that it's not persistent, right? It's not something that we collect first and then go and see and fetch it from the database. We do it live. That means that you have the most granular access to your live network data.